So our next speaker today is actually kind of a legend. Like I remember he having this was pointed out recently by Chris on Twitter. He had a blog about Zen framework stuff, version 1. This was like late 90s, early 2000s. So it gives you the measure of how a legend this guy is. So today he's going to talk about APIs. So please welcome to the stage Rob Allen.
Gary mentioned, it's so wonderful to get a round of applause when you start your talk, because you've already appreciated and you haven't even seen how bad this is going to be. One thing that happens when I come to conferences and I tell my family that I'm going to be speaking at a conference is that my youngest son will tell me, no one will turn up for your talk. They will pick another talk, Dad. Every single time. It's a bit of a stick now. And I went, aha, joke's on you. This is a single-track conference. They have to be in my talk. So, and here you all are. So I am now going to prove to my son that you're all here by taking a picture of you all, and to prove to myself for the future that there were people in my talk. So there we go. There's lots of people in the room. It's wonderful. Okay, my name's Rob Allen, and we're going to be talking about APIs. Myself, I write APIs, or my company writes APIs now, because I have people that write APIs for me, which is a wonderful position to be in. Try to get there. I also integrate with APIs. So I write applications, I write PHP code, I write some Go code that talks to other people's APIs. And I have strong opinions about atrocious APIs, bad APIs. So many APIs that we integrate with are not as good as they could be. They are not suitable in so many different ways. So what I want to talk about today is a little bit about what I consider to be the way to build a good API and what is the right API for the job you're trying to solve. And we're going to start with the concept of fit for purpose, which is another phrase for the right thing for the job. There's no point in writing any code, let alone an API, if it doesn't solve the problem you're trying to solve. As Chris was talking about being able to interpret business problems into code, that's the same thing that we do with a good API, an API that's fit for purpose. What we mean by that is that the users of the API, your client developers, if you're the writer, can use their API to solve the problem they have. If they cannot solve the problem they have, so if we take, for instance, Gary's SMS company, they need to be able to send an SMS via an API. If they can't do that, that API is not fit for purpose. It is useless. It doesn't matter how awesome the code is. It doesn't matter how well tested that code is, or how resilient that code is, or how well it will scale. Complete and utter pointlessness if it is not fit for purpose. So we're interested in what it takes in terms of our choices of architecture and the way we build our API to make it a great developer experience and fit for purpose. So what do I mean by API architecture? We could break API architecture down into 3 groups, roughly, in sort of broad general terms. RPC-style APIs, RESTful APIs, and GraphQL APIs. They've all got pros and cons. They've all got good things, they've all got bad things, they've all got some things. Which one you pick depends upon which balance of the features and your requirements matches the problem you have. What works best for your situation. So what I want to do next is take a little bit of time and talk through each style of API and look at them. APIs could be realized in any style. It literally doesn't matter. Going back to that comment that no user of an application cares which language it is written in. No user of an API cares which style it is in as long as it works. But Some of them make more sense than others. Which one makes the most sense for you? And the answer, of course, because it's software, is it depends. RPC APIs, these are the old ones. This is where we all started. Remote procedure call. The clue is in the name. You call a function on a remote server. That is literally all it is. I have my code here. There's some functionality over there. I call a function. That code over there runs. Most common implementations, JSON RPC, SOAP, and gRPC if you're fairly modern and doing stuff with Google stuff. Nobody else uses it, I think. Tends to require a schema. Anything that looks RPC-like tends to have some sort of schema. In SOAP world, we have WSDLs, WSDLs, which are an experience in and of their own right. In the gRPC world, we have protobuf definitions, which again are interesting in and of themselves. But you must have a schema in order to understand what functions you can call, what parameters they take, and what the return is. You need to know that information. Let's look at an example of an RPC API, JSON RPC. Let's pick something really modern and slightly controversial. Ethereum. They have built an RPC API in the 2020s. So I said RPCs have been around a while. They are still being built today. That's part of what I mean by it doesn't matter which one you choose. Pick the one that makes most sense for your particular environment, your particular situation. And the Ethereum people clearly picked JSON RPC as their choice for their API. So this is what it looks like. We have a request. We make a POST request to port 8545, and we pass in some data in JSON format. The clue there is JSON RPC. There's some metadata there, a version of JSON RPC, an ID number, and then we've got our method name. So back to we are calling a method, net_peerCount, and then we have to pass in the parameters to that method. There aren't any in this case. And then the server returns the answer in a property called result. And apparently we have 2 peers at the moment. That's it. RPC, make a function call on another server. gRPC, basically the same thing, but it's entirely a binary protocol, which makes it way harder to reason about and much harder to debug. As it's a very binary protocol, you tend to use a client library. So again, here we're using a PHP one, so we just call a get feature, I think it is on our client, which is the function name, and we get back our result. gRPC is quite a neat protocol. It's quite a nice one. If the efficiency of the data link is the most important thing to you. It's a binary protocol, which makes it very small for sending data over the wire. It supports two-way streaming. So if you need to go backwards and forwards at the same time, gRPC is quite good for that. There's absolutely no browser support for it, though. So if you need that, this is maybe not the best place. RESTful APIs. I wanted to make a bet that at least 90% of you have made method calls against a RESTful API in your time. And a good proportion of you have probably written something that looks like a vaguely RESTful API. It's more of a guideline than an architectural style at times, because it's really hard to do it right. But basically, we're talking about leveraging HTTP. So we operate on a representation of a state of a resource through HTTP verbs, which is quite a mouthful there. But REST stands for Representational State Transfer. So there's a lot about the concept of state and transferring that state around. And we tend to do that through HTTP. So obviously the HTTP verbs, get, post, delete, put, and patch. Those are your operations that you do on your resource to change its state. It's HTTP native. It tends to think in HTTP. The RFCs matter when you're building a RESTful API. Most classic example here is you must follow status codes if you are building a RESTful API. They have meaning, mostly because we believe in the layered system. If you read the HTTP specs, when you have your phone and you're talking to a remote server, it's not necessarily a direct connection. There are multiple proxies in the way. It goes from your phone to a proxy, to another proxy, before it ends up at the server where the application is. And RESTful APIs will leverage that feature of the internet in the way that other APIs don't. That's the concept of uniform interface. In principle, a well-designed RESTful API has predictable endpoints, and it has predictable operations. If you know how to operate a state transformation on one particular part of the API, you can operate on another part of the API. And finally, it has something called hypermedia controls, which is a really, really clever way of saying a link. The web obviously works with links. That's how Google works, for instance. You search on Google, you get a list of links, you click a link to go to the page that you're interested in. That is hypermedia controls. A RESTful API does the same thing. It has links in its resources so that the client developer knows what to do next. That's a bit most people don't do when they write something that looks mostly like a RESTful API, because that bit's hard. That bit means that you had to design your API, and people are not very good at designing APIs, from observation at least. Doesn't mean that RESTful APIs are quite discoverable when they're done right. So here's a RESTful API. We're doing a put to a users collection with some sort of random number, so it's probably creating a user, probably idempotently, and we're passing in a name and email, so we've now got created our user, and we get, what have I done here? Oh yeah, then we have to set the content type to the HTTP thing. You must set the content type for the data coming through. This is application JSON. Ironically, in JSON RPC, you don't need to set the content type because it's known to be JSON. But for a RESTful API, you certainly do. You get a response like that. You're going to get a 201 created. So you're going to get a status code back. It's a RESTful API, the status code matters. You're going to get an E tag back because it's HTTP native. And this is the way that the proxies can help themselves work out if anything has changed since the last time it retrieved this resource. And then you're going to have your content, whatever that might be. So it's a particularly simple one. We send back the data, and we send back one of those hypermedia controls to tell the client where this particular user was created. That's about it. That's what RESTful APIs basically look like. We get to GraphQL APIs. How many people have written a GraphQL API? A few. In PHP? Slightly fewer, but yes, some. Good. GraphQL is the new one on the block, so I'm not totally surprised that there's sort of less experience with it. It's also got a remarkable amount of evangelism around it, which can make it quite hard to see what's going on with it. But what we're looking at is a system where you can retrieve only the data that you need from the consumer side. So GraphQL is very consumer-focused. You specify exactly which properties you want to have returned to you. And you can nest it. So you can say, I want this list of authors, and for each author, I want their last 5 published books. And for each published book, I want a list of reviews, or something like that. And you can do one request that will return all that data to you. Exactly the properties you want. That is the key feature of GraphQL. The client makes a decision. It has a self-describing schema. So you can query a GraphQL server, and it will tell you how it works. That's also quite a nice feature. Side effect of that is that we now have an ecosystem of tooling that works with that. So you can use Postman against a GraphQL API, and it will autocomplete for you, which is magic, as Gary really likes this autocomplete. So how does it look? This looks a little bit like JSON, but don't be fooled, it isn't. It's some weird language. It's very much its own DSL. Reading and writing actions are separated into two sets. We have queries and we have mutations. You can tell that this one is a query because of the first line. It's query. Knowing how one works means you don't know how the other one works. So knowing how the shape of a query is doesn't map at all to how you would necessarily mutate that object. The two are completely and utterly different. It's harder to find out how to do the mutations without reading the docs. So let's look at our query. We specify what we need. We want an author object thing to come back. And then in brackets, I can filter to limit what author I'm getting back, or which particular one. So in this case, I want Anne McCaffrey back. And then I specify exactly which properties I need. So I want the ID of this author, and I want their name. If there are any other properties in the database table related to that author, I do not care. I don't want the bio. I don't want their picture. I don't want the reams of other pieces of data in there that are going to slow down my query being transferred down to me. I'd also like the books that this author has written. So the books is a collection. You can tell that because it's got a plural. That appears to be a convention. There is no rule about it, but a convention in GraphQL, plurals for collections. Again, we have limiters or filters. In this case, I just want the first 5. And then again, I specify which particular data I want. Now, from the collection, I get the total count. And this is the point when you get to discover the word graph in GraphQL. Because now I have to get the edges in order to get the node. So you need to know a little bit about GraphQL, a little bit about graphs and stuff like that to understand how this works. So the node is a word I have to use in my query, and that means the book. So the properties that I'm specifying, ID, title, and published, are the properties of the book, but we've written node because we're in the collection of books, and it's a graph. And then we get the response back, and the response back is exactly what we asked for. No more, no less. It's in the data property, and then there's my author with my ID and name that I asked for, and then there's my books collection with the total count, and then there are my edges, which is a collection, clue by the plural, and for each book, which is called a node, we have the ID and the title. It works remarkably well. Mutations go the other way. So to add an author to the system, in this particular API, I use create author. In another API, it could be new author or add author. You have to go and look that up. There's no convention for how you create a new object on the API. It's whatever word that particular designer has chosen. And then you pass in the properties you need. And then finally, you can say, give me back these particular pieces of data once you have done the work. So it's all about consumer focus. And I get back my response, returning the data I've asked for. Okay, there's a whistle-stop tour of RPC, REST, and GraphQL. So you've seen all three. You're about to design a new API. Which one do you pick? Do you pick a Lamborghini or do you pick a Ferrari? I'm in Italy, so I picked Italian cars. And also they look cool, and my son is really into Lamborghinis. It's a preference. It doesn't really matter whether you pick a Lamborghini or Ferrari. unless you're a super fan. They both do roughly the same thing. They go reasonably quickly, very low to the ground, and they're really, really expensive. It's totally valid to pick the API style that you would prefer to write, because you will write a better API. Nobody likes writing something they dislike and hate. Nobody here wants to write a SOAP API in 2022. Do you? Other than Marco, who loves his types. He's got some XML in it, Marco's there. Well, Lamborghini or a truck? Is this a preference? Or are we picking on something different, picking different criteria now? Depends what you're optimizing for. If I need to go really, really fast, then probably the Lamborghini is going to be a better choice. It's going to corner better. It's going to be more fun to drive really, really fast. If I need to move all my son's kit to university, which I will be doing in a few months' time, maybe a Lamborghini is not the best choice. I mean, there's not a lot of storage, and my son doesn't play golf, so I'm thinking the truck might be a better choice for moving big lot of stuff around. So there are some important differences between the different API styles, and they might matter in your situation. In which case, it's worth paying attention to them and going with the API style that matches better to your requirements. So the considerations we're talking about here, what's it going to be used for? Is response customization important to you? GraphQL is a query-first language. You choose your fields, you choose your nested resources, etc. RESTful doesn't work like that. RESTful is all about the server giving you the data. You can have a way to say, only send me back some of the data. We can do basic representations, or we can do full representations. We could even create a DSL and have a little query string parameter to specify exactly which fields we want back from our RESTful API. You can do that. Don't, but you can do that, because that's not the way REST thinks. If you need that, GraphQL is a better choice. RPC, you just call in a function. You're going to get back data it gives you. You don't get any choices ever. Nobody writes functions that give back half the data that you asked for. It just doesn't happen. So RPC works completely and utterly different. The nested thing is a bit interesting. In GraphQL, we've said we can nest, so that means we're only making one HTTP call rather than multiple that you would do in a RESTful API. However, HTTP 2 has been around for a while now. We should be using HTTP 2, and that negates most of those issues. So there are choices there. It's about performance and where you want the performance to be. REST and RPC is all about the server performance. The developer of the API chooses the amount of, or the performance parameters of the API. We pick the set of properties we're going to send down for every representation, and hopefully we document them. GraphQL, client performance is the most important thing. So if your app is all about client performance, GraphQL is where you should be looking. There's some complexities around that, aren't you? Mostly around the fact you can DDoS yourself. Caching. GraphQL, RPC, you cache at the application level. That's it. You have to cache at the API level, at the application layer, if you're going to do a GraphQL API. RESTful APIs also cache at the application level. You have to do that. You have to do that in any application. In addition, a RESTful API can cache at the HTTP layer as well, because it's HTTP native. And the specific thing there is that you use GET requests in RESTful APIs, and in RPC APIs and GraphQL APIs, you use POST only. So the HTTP layer cannot cache for a GraphQL API. RESTful APIs, it can. It's a data transfer issue related to that, which gets quite interesting. Well, interesting for someone like me who's into this sort of stuff. Can't talk for all of you, obviously. Let's say I want to retrieve a thumbnail image for a user, their avatar. How do I do that with GraphQL? I create a query object. I'm going to put an avatar in. I'm going to pass a user ID in. I'm going to get back a data blob in JSON with the base64 data. RPC, basically the same thing. Call a method called getAvatar. You're going to get a set of data back in a JSON object, which is your JPEG information, or GIF information if you happen to be Marco on GitHub, for instance. Then we've got REST. REST, you get the choice because it's HTTP native. If we do a GET request and set the accept header to image JPEG, the REST server is going to send you back the image data directly, so your browser or mobile application can display it like that, with no decoding on the client side. Or, if you really, really, really want the base64 encoded version of that JPEG image, you could just send an accept header of application JSON, and you would get back the same sort of data shape as you would from GraphQL or RPC. So this is one of those cases where HTTP native thing gets more interesting. And as a result, you will notice in a lot of GraphQL APIs, there are a few endpoints that are actually HTTP-ish. There are GET requests to retrieve files and things like that, because it is way more efficient. So you'll tend to do that. And that is perfectly fine. It is more than okay to mix and match for the right parts of your application. If you go and Google around GraphQL, all the articles will tell you 2 or 3 things. Firstly, it will tell you how awesome response customization is and how the N+1 problem has been solved with GraphQL. And then they will also tell you that you never need to version again, because GraphQL can do version via evolution. They are lying. It is completely and utterly possible to screw up a GraphQL API as easily as it is to screw up an RESTful one, HTTP one. Also, RESTful APIs can version via evolution. RPC APIs can version by evolution. All it means is don't break backwards compatibility. It's not that hard. You just have to live with the decisions you made in the past. And programmers are so bad at doing that. We loathe living with the decision we made in the past, and we will try to change it. That breaks backwards compatibility. Some projects are much, much better at this than others, and you obviously have to give shout out to WordPress as a particular project that is really, really good at understanding the importance of backwards compatibility for their user case. And again, back to your APIs. If backwards compatibility is important to your API, then you need to understand how to do versioning via evolution. You absolutely must understand that, and you must cope with living with the decisions you made. I'm sorry. One thing that's nice about GraphQL, though, is that you can deprecate stuff and delete stuff, particular fields in your response, much, much easier than you can in any other API architecture, because of that response customization thing. If all my clients are specifying exactly which fields they want to come back from my user object, and one of those fields is never used, I can see that in my metrics. We do metrics. If we don't do metrics, start doing metrics. It can be useful. you can deprecate a field and say this field is going away in 2 years' time. And you can start using your metrics to discover that that field is being removed as your improved field starts getting used. Awesome. And then there'll be one holdout. And that one holdout is your best paying customer. Every single time. But because you know it's your best paying customer, you can go and talk to them and maybe provide support to help them move to the new evolution and get rid of that property. You can't do that with REST because you literally have no idea if anyone is using any particular field in your response. Design is always hard. It's extremely difficult to design a good API. GraphQL, you need to control your naming. You also need to choose what can be nested. It's not a free-for-all. Someone still needs to design which edges are connected to which nodes. If you get that wrong, your API is not fit for purpose. You need to balance the developer experience of the API versus the internal app capabilities. This is what I was talking about accidentally being able to DOS yourself. It's really, really easy to accidentally get into a situation where I request an author, I ask for all the books, then I ask for all the authors of all the books, and then for each author, I ask for all the books again. I can write a GraphQL query that will do that. It's a bit pointless, but it's possible. And guess what that does to your application? It falls over. It's too complicated. It's too much resources. So in the GraphQL world, they've introduced this concept of complexity. So you will notice, particularly if you're using something like the Apollo server, which is quite a good GraphQL server to put at the front end. It analyzes the complexity of the query that's coming in and then decides, is this allowed to run or not? And it will error and say, no, that query is too complicated. Split it up a bit. Do something different, because we can't run that and maintain quality of service. That's design. Design is hard. On the RESTful side, design is also hard. You've got to balance the data sent versus the number of requests that need to be made. That's a design decision. You don't want your clients making too many calls, but equally you don't want to send back bucket loads of data that nobody wants. The uniform interface encourages consistency. It encourages an easier learning curve, but only if you actually write your API to follow it. So I've gone through all this stuff. There's your considerations. You've got to pick your Lamborghini or truck. It's your choice. I cannot make this choice for you. It's your application, not my application. In REST, the structure of the request object is defined on server. In GraphQL, you define the object in the client. A big part of GraphQL is eliminating multiple round trips. If that's not a pain point for you, then don't optimize for it. That's a bit pointless. My company don't do round trips. Our API is not a round trip type API. We wouldn't care less. Doesn't matter. I've seen it argued that GraphQL and REST, comparing them is a bit like SQL and NoSQL when you're picking your database. There are strengths and weaknesses to both, but for an awful lot of applications, you can use either. Same holds true here. I like them both. I'm happy to use either if it is well designed. I loathe working with both of them when they're badly designed. The other part about this is developer experience. Not only have we got our API style, we've got how is your developers going to use it? What is their experience like? If it is bad, then that API is not going to get used anyway. And there's a number of things we need to think about there. We need to think about how correct it is. If your API is not correct, it is really, really hard to work with. Now, what do I mean by correctness? For PC, you are writing a function-based API. Your clients are making function calls to you. They are thinking in terms of functions. Your design should think in terms of functions, and it should be correct for doing that. For REST, it's all about the HTTP. This means the correct use of HTTP verbs. It means the correct use of status codes. You do not send back error messages with a 200 OK in a RESTful API, ever. On the flip side, you do in a GraphQL, and that is the correct choice. So, you use the correct use of media types, content type, accept, etc. for forward evolution. We're going to use hypermedia. That's how you do a correct RESTful API. And for GraphQL, you think in terms of relationships. You think in graphs. The clue is in the name. Get it right. Think about your design in terms of edges and nodes, and you will get a far better GraphQL API. Define your type correctly. GraphQL thinks about types a lot. Types matter in GraphQL. Design them reasonably well. Get them right. Helps a lot. And use the conventions. GraphQL is fairly new. It hasn't got a whole string of standards, but there are conventions that are in play by the big players. Follow them. Use things like the global object ID, because it's amazing when a GraphQL API supports it. And it's really frustrating when it doesn't. Pagination. The Relay project has got a specification of pagination that most GraphQL servers support. Use that one. Don't invent your own pagination solution, because the GraphQL community has picked one. Use that convention. Your GraphQL API will be correct. And naming things is hard. Naming things is always hard. Think about your names when you're designing your API. Error handling. I always talk about error handling when I talk about APIs because it matters a lot. It really, really matters. When you write an API, you're going to have a developer that integrates with your API. Their first experience is going to be an error message, nearly always. Because nobody reads the docs. They're going to try it out. And it's going to fail because they didn't know they need to authenticate. Or they misunderstood the structure of the response or the structure of the request or whatever. So your error representations must be first-class citizens. Pay attention to the way you display and handle errors because your developers interact with them a lot. In REST, you're going to use status codes like 4xx and 5xx, and you're going to use RFC 7807 for your error formatting. Or JSON APIs, that's not a bad one. But pick an error format, be consistent with it. On GraphQL, a remarkable amount of the server software will return a really cryptic error message straight to the user unless you catch it and interpret it. It's worth doing that. Because unless your developer knows how GraphQL APIs are built, that error message probably won't make much sense to them. Have a top-level errors section for exceptional scenarios, service down, rate limited, things like that. Otherwise, domain errors go within the body of the nested query, because if you can return most of the nested query, do so. That's the convention within GraphQL. And as I said, it's a 200 response because the HTTP call worked, and GraphQL is not an HTTP native API. It would be very, very strange for a GraphQL API to return a 4xx error state. That'd be really weird. It's possible if you really screw up the query, but it's really unusual. Documentation. Although nobody reads the documentation at the start, they do start reading the documentation when they get frustrated. So that's the point, it needs to be right. Two things here. You need a reference. You need to document every single field in your API. You need to document its type. You need to document any validation on it, how long it is, whether it's required or not required, whatever. If you're doing GraphQL, that's built into the system, which is really, really helpful. If you're doing REST, use OpenAPI spec. The thing about REST is you can avoid doing it. It's not a requirement. Ignore that. Always write a specification for your API. And you're going to need some tutorials. A reference is the what of the API. The rest of your documentation is the how and the why. And developers need that as well, so write some documentation. And that's all I want to tell you about APIs and which one you should be picking. What's the right API for the job? I've looked at RPC, I've looked at REST, I've looked at GraphQL. We've looked at the differences between them, whether they're client-focused or whether they are server-focused. It's up to you which one makes the most sense for you. And I will reiterate that the one you prefer is possibly a valid choice for your particular situation. Arnaud Laurent, the API handyman on the interwebs, said this: if you suck at providing a RESTful API, you will suck at providing a GraphQL API. Doesn't really matter, the API style. The design matters. Second attempt will be better than your first attempt, which is why people who write GraphQLs having written a RESTful API tend to write a better GraphQL API. They have more experience and they know what didn't work last time. And that's it. Thank you very much. I hope you found that useful and joined in. And I think we've got some time for questions. Or we can break off early for coffee. No, we can't. We've got no talk, I think. I can break off for coffee.
Okay, seems there are no questions. All right, so I do have a question for you, actually.
Okay.
Have you ever had the experience of reaching like these scaling issues where GraphQL was the answer just purely for optimization purposes, but you had you regretted the decision?
No. There are probably 50 companies in the world that have a scaling issue that big that couldn't be solved with REST or GraphQL. The one of the companies that does is Facebook. They have a scaling problem that the rest of us will never, ever see. They came up with GraphQL, so it clearly does help for those sort of scaling problems when you want to when you want to control what's in the client side as well as the server side. So going back to GraphQL being consumer-focused, the key thing about a consumer-focused API is that your business logic lives on the client as much as it lives in the server. So you've got to be happy with giving away that control. Facebook is mostly a closed ecosystem. I don't know if you've noticed. Anyone noticed? Very closed. One thing about closed ecosystem is that they control the client. So the client is merely another part of their application. So from their point of view, it doesn't matter whether the business logic is in the client or whether it's in the server API. It makes no odds to them. They control both ends. And they seem to like microservices because this is just another extension of a microservice. Other situations don't work like that. So where I work at Covey, for instance, we most definitely want to control what we give to our clients, and they have no say in this. We don't trust them in the slightest. So as a result, a RESTful API makes a lot more sense for the work I'm doing at the moment.
Thank you.
No worries.
We have a question there from Marco. Yeah, I'm going to give you the microphone.
You need the mic for people not in the room.
All right. How do you feel about GraphQL for reads and RPC for writes? Is that too messy or is it viable?
It's doable. I don't think you gain much because GraphQL's mutations is quite RPC-like anyway. It's quite RPC-ish. So you may as well use it because I think you will lower the learning curve for your client developers. And most people with an API, their client developer engagement and use of it is probably the biggest stumbling block. So it's it's easier for them if it's all in one tool than if you split the two. So you're way more likely to put in a little bit of RESTful GET requests than you are to put in a different way to do mutations.
So say I am like the rest of the world currently using REST APIs, but I'm interested in introducing GraphQL. What would be the first sensible step to, make that move?
Oh, what's the first sensible step? Now, there's a good question. It depends on the problem you're trying to solve and why you're trying to do it. I would go one of two ways, I think. If I've got a new subsection of the app that needs an API that is mostly independent from the rest of the app. So let's say it's hitting a different market segment slightly. So we've got different developers hitting it, or maybe it's an administrative one rather than the user-facing one, something like that, those sort of changes. That would be a good one that maybe you experiment on. That's one way to go. The other way to go is that there's an awful lot of GraphQL APIs out there that are front ends on top of a set of RESTful APIs. So I would also investigate whether to use something like Apollo. I keep mentioning Apollo because it's the big one in the space. Something like that in front of your RESTful APIs. There is no rule that says an API has to have a database backend. An API can have a API backend. That's fine. And how you store your data is immaterial to the API you're writing. So you can store it in S3 buckets for all I care. So you could go that way. You could put a GraphQL in front of your RESTful API and then experiment at the same time. That would also work. In general, I would advise you to look at people who've done it before. So the obvious one to look at is GitHub. GitHub have got an amazing RESTful API. And they've got a really, really good GraphQL API. And what they've also got is fantastic documentation on both of them. So you can compare and contrast really well. So if you want to look at the differences, go and look at the way GitHub have built their RESTful API and how they've built their GraphQL API and compare them. And notice how much documentation there is in both cases. There's a lot of documentation required. It's best I've got, really.
All right, we have a question from people following from home. Eugene asks, are there any frameworks that you recommend to do server-side GraphQL or RESTful APIs?
Not really. Like Chris here, I'm very old school and started PHP back in the olden days. So I tend to write things more from scratch than maybe I should do. And obviously, as one of the Slim framework people, I'm going to be using Slim by base wherever I can. For GraphQL, I don't do it enough and haven't done it enough to have strong opinions. And I would recommend going to that community and starting there. There seems to be a lot of interesting projects in the JavaScript space and the Node space. So I would almost certainly start looking at those applications first.
Right, any more questions?
One over there.
Oh.
Is there any valid alternative when we talk about GraphQL subscription in the RPC or RESTful APIs?
So what do you mean? Could you?
Any valid alternative when we talk about GraphQL subscriptions on the RESTful and RPC world?
Don't really know. Sorry. Alternatives. No, I would just stick to what they have. So no, sorry. I got nothing. If you want to come and talk to me later, maybe we can flesh it out a bit.
All right. So I guess we are done for now. Give it a round of applause for Rob Allen.